Markov chains are Markov processes and then their relatives hidden Markov models. They are mostly used in gene prediction, and since we know about probabilities, so far we have seen them in previous sections. Let's go and talk about Markov chains right here. I will introduce the topic. We see that they are associated with stochastic processes. We'll define what these Markov chains are, and then we will look into what a Markov property is, and we'll talk about a couple of other features before we conclude. So Markov chains, they were introduced in 1906 by Andrey Markov, and they deal with stochastic process. So what is a stochastic process? So any process that has some underlying probability. So anything that has some probabilities associated with it can be treated as a stochastic process. Generally, these Markov chains and models, they were used when people were working on speech recognition. So when you are you are designing some systems and you are recognizing those speeches. So sometimes you have data coming to you, and then some frames, they might be interrupted or missing. So what is the probability here that you are getting the right frames from the right person? So in those kind of situations, they were used a lot. So obviously that field then propagated their utilities, and finally they were used in biological or bioinformatics algorithms also. Here is Andrey Markov, Russian mathematician. He is best known for his work on stochastic processes, and primary subject of his work later on it was known as Markov chains or Markov processes. A Markov chain is a sequence of random variables. So we have random variables like x1, x2 and up till x3 with finite set of states. So those numbers, those variables, and they are coming from different states. So that is the idea or the main concept behind this. What is the Markov property? A Markov property is the outcome of an event and depends only on the outcome of the previous event. It's just like a chaining process. So you have a chain where you can see that this part of the chain is attached to this one, and then this is attached to this one, and this is attached to this one. In order to go there, you need to traverse them one by one. This guy depends on this guy, and this guy depends on this. It has nothing to do with this, right? So these kind of situations where we have those states which are chained together, we can say that the present state depends upon the previous, and the next state depends upon the present. So this kind of chaining process, we call it as they are having this Markov property. So far what we have seen is that there is a set of states. We have S1, S2 and S3. The process starts in any one of the states and moves successively from one state to another. We will define these states when we talk about those nucleotide strings, like the positions. So positions within your amino acid chain or positions within your DNA, we can take them as different states. So each move is a step from one place to another, guys. Okay, so we use directed graphs in order to represent these chains. How can we represent them? So we can take the states as some circles and we connect them with some edges while putting their probabilities on those edges. So in this case, we can represent them while using some kind of directed graphs. Where vertices, they represent states, and arrows represents possible movements, right, in one unit time, and the numbers, they will show you those probabilities. So we'll look into this example right here. So we have a state 1 in which the system is in, and there is the probability that from this state it will move into state 2, and the probability is half. So in this case, it's kind of a fair trial, and from this system, from this state 2, it can get back to 1. From 2 it can go to 3 with a probability of half, or 1 by you can say it's 0.5, or from 3 it can get back to 2. So just have a general or a brief idea what is about, and we'll talk more in the later sections. So far what we have seen in this section is that a stochastic process in which probability of next state to occur depends on the present state. That kind of a stochastic process is called as a Markov process.